Cool. And next, I think today we have our awesome speaker, Jeff, who is Chief Architect at Fred IT Group. And Jeff will introduce you some cool stuff about Azure API Management. So you will learn from quite a few demos about how to use Azure API Management and some new features, common use cases. I think that'd be cool. Okay, over to you, Jeff.
Great, thanks. I'll start sharing.
Yeah.
Right. Hello, everyone. Today, I'd like to present on API management. My name's Jeff Gilberto. A bit of background on myself. My family and I have been living in Auckland since the end of 2006. I'm currently Chief Architect at Fred IT, a leader in the Australian pharmaceutical software industry. I also collaborate as an author, software developer, and as an indie game developer. Thanks for having me. So what we'll cover, I'll provide an overview of APIM and highlight major features of APIM. I'll move fast through these as I really want to explore capabilities of APIM that I've seen organizations not use to their full potential. Compared to other Azure services, APIM is different than most as it provides an offering that merges business and technology concerns. This means when we approach APIM, we need to look at it with a different lens than we would a function app or a database service. I also wanted to show some patterns as I feel these show the strength behind APIM. This does mean this will be a demo-heavy presentation, so we'll see if the demo gods are with me tonight. Saying that, I do recognize there will be those on the call with deeper knowledge of APIM, DevOps, load testing, and other aspects of the presentation. Please post your thoughts in the chat so we can discuss at the end. And if you see me struggle, please speak up and help me out. Let's get started. So first, an overview. Azure API Management provides organizations with a comprehensive set of tools and features to create, manage, and secure APIs, enabling them to expose their digital assets in a secure and controlled manner. Microsoft describes APIM as having three distinct components. The API gateway acts as a facade to the backend services, allowing API providers to abstract API implementations and evolve backend architecture without impacting API consumers. API providers interact with the service through the management plane, which provides full access to the API management service capabilities. This can be through the Azure portal, Azure PowerShell, Azure CLI, Visual Studio Code extension, or client SDKs. The open source developer portal is a fully customizable website provided so you can easily provide documentation about your APIs. Before we start on the features, let's discuss a simple scenario that we will use throughout the presentation. So here's a typical scenario supporting the ability to retrieve and add patients to a database. This was implemented using Azure SQL, Function Apps, and Azure Storage Queue. Our retrieve patient API supports HTTP GET operation. The add patient operation is triggered when an entry is added to the add patient queue. So now we want to expose this functionality. This is where APIM comes in. There are a couple things to note about this example. First, we've chosen to expose our APIs as RESTful, where they were originally designed as RPC. This can be referred to as API wrapping or API bridging. The advantage of API wrapping might just appear like personal preference, but if you imagine a scenario where a company might have dozens or even hundreds of APIs created at different times or in different technology, then APIM is a great mechanism for presenting a consistent offering to customers. So let's see this in action. Right, I'm using Postman just to test the API and in this case, warm it up. So first, I'm going to be doing retrieve patients. Sorry about the size, but hopefully you can read it. I'm calling a dev instance of APIM where I'm using the RESTful endpoint. So you can see patient doing a GET operation. if I send that in, I'm going to get eventually a total count of the patients in the database, and then just an array of pretty much junk data that I pushed in. You can contrast this with the function app. So you'll see here the function app is using a RPC style endpoint, but it's in essence basically doing the same thing. In the real world, you could imagine maybe this older endpoint returns XML, and then you translate an APIM to more of a modern RESTful interface. And the other thing to point out is here, again, off the dev APIM, I'm posting a JSON payload to the queue, which then is processed. So this is just an acknowledgement that it was added to the queue. And so we should see then our count go up from 259, hopefully. Uh-oh. First part of the demo. Okay. Something's funny happening already. Let's just send that in again. Oh dear. Well, I'm sure we're going to stumble upon what has broken in a second. All right. Moving on. Always the way with demos, isn't it? Right. Oh, and the another pattern to highlight is we have the basis when it works of queue-based load leveling. The main benefit here is to reduce the impact receiving many requests in a short period of time that might have on our application. So you can basically get the idea that we are smoothing out our request received rate. So let's take a look at how this was implemented. Right, here I am. I'm in APIM. I'm sure some of you have seen this before, but basically we have our endpoints here. And so I'm going to take a look at the post operation, which is where we're posting to the queue. And so if we take a look at the policy, again, apologies for the size, you can get an idea of the way that we define our different APIs. So for now, if we overlook the set body and concentrate on the right queue, here with this set body operation, we're basically wrapping the payload that we received as a base 64 encoded message. We are directing this message to a particular backend service, and then we're setting some headers that are required. Authentication, we're using managed entity, which we'll talk about in a second, and we're performing a rewrite of the URI to the messages format. So all we've really done here is implemented the defined message, and I'm just bringing that up now, that of the put message, which they call it put, but it's actually a post. Let's see if I can zoom in a little bit. Nice. So you can see it's a post message to the messages endpoint, and further on you can see the different request headers that are required. So nothing too revolutionary, but a nice use of APIM, where we use the functionality of APIM as opposed to standing up another service in order to integrate to the storage queue. So the demo I put together centers around two deployments of the patient API, a development environment and a production environment. I'll be using DevOps, Azure DevOps, and the API Ops framework for CI/CD. In addition to the monitoring within APIM, I will be using application insights to visualize what is happening within the APIs. And to create some activity against our environments, I'll be using Azure Load Testing Managed Service. So that we can start to build up some activity, I'll launch some tests now. So this is the Azure load testing service, and I've defined 2 tests within it. Basically, they're just JMeter scripts. So what I'm going to do for the first one is I'm just going to go ahead and start it. So this is against the dev environment. And I'm going to do the same thing against the prod, but let's just pause a second and take a look at some of the features of the load test suite. So we are able to configure the tests. So just to give you a little bit of understanding, we can give it a nice name. The test plan is just a JMeter file that's been uploaded. In parameters, I've been able to feed it specific parameters used in the test. For example, the endpoint, the production endpoint for the test plan. It's the same test plan, but I needed to use different subscription keys. We'll talk about that in a second. The load's also variable. So I've set this up to be on 2 instances, but because we want to push the envelope a little bit, I'll increase this to 4. The other thing I can do is create some test criteria. I haven't in this case, but if people are interested, I'd love to come back and talk about load testing. And the other aspect is we can monitor different aspects within Azure itself. And this is one of the great features of the load testing suite, where you can actually hook it up to different services that are involved. So in this case, I'm bringing in aspects, metrics from the database, from APIM, and also from application insights just to monitor. So I'm going to go ahead and apply that. And it'll kick me out, and I'll go ahead and start the run. So we can give it a nice name like demo. Hopefully it'll work. We'll just kick off the start. So what we'll have, actually, what I'm going to do is I'm going to switch back to the dev instance because he should already be showing a bit of activity. Oh, did I not hit run? I don't think I hit run. Sorry, everyone. I'll go back to the dev instance. And what we'll see it kick off in a second. And because of that, whoops, I'll pop back to prod. And we'll see if this guy is kicked off. All right, good. So he's actually started up. So you can see that we're doing our 4 instances. Looks like there was an initial delay on the startup of the services, but now it seems to be ticking along fine. So you can see the response times showing up. This is the number of requests per second. So looks like we're maxing out. Oh, well, we're getting up to around 120. So that's quite exciting. This is probably the most exciting thing for me is our error count at the moment is 0. So I like that. The other thing to point out is we'll start seeing some server-side metrics appear. So let's just let this run for a bit, and we'll go back to the presentation, but then we'll come in and take a look. Yeah, so we can start seeing it ramp up a bit. Good stuff. So the first feature I'd like to highlight is API lifecycle management. APIM provides tools and features to create, version, and publish APIs, making it easy to manage the entire API lifecycle from creation to retirement. It allows for versioning, deprecating, and retiring APIs, ensuring smooth updates and transitions. So let's have a look at that. So again, back in API management, we can see that we have a single version of the patient's API. The versioning scheme here has been chosen as path. Other options are header and query string. And in case it's not obvious what I'm referring to, if we take a look at a test, for example, we can see that the versioning scheme is within the URL shown in the path. versioning is primarily used when there are breaking changes. The Azure Architecture Center provides good advice on API design, including what is and what is not considered a breaking change. At the end of this presentation, there's a page of useful links so you can read up on more information about that. Another mechanism for lifecycle management is revisions. So what I wanted to do is I wanted to post in the chat a quick poll because I'm curious to see how others are using APIM. So bear with me as I navigate around. Okay, so for those of you using APIM, it would be great if you were to react to this post. So take your time, but for those using APIM, do you use revisions? Thumbs up, yes, no laughing, and no idea. What's that surprise face? All right, okay. So let's check back to see how the load test performance is doing in order to show how revisions can be used. Navigating is a bit of a challenge. Okay, here we go. So I'm going to actually pop back to the dev instance because it highlights what I want to show a little bit more. So you can see here we only have one instance of the engine running. Looks like our performance is a little bit more chaotic. Usually it's not this chaotic, so I don't know what's happening. No errors, so that's great. Requests per second, we're not getting very high. You can see we're only around 40. What I wanted to show is this. The CPU percentage is very, very high. So a little bit better of a view is what we have over in the SQL database view. So I'm on metrics and I'm looking at the DTU percentage. So you can see that we're actually around 80%, which is quite high for what we're doing. We're just basically sending in a request to get, I think it's around 100 users, but it's not the most efficient query. So what I'm going to do is I'm going to use a revision to put in caching on the service. So the reason why it's a revision is that it's not a breaking change. So no one needs to be alerted of this in a similar way that you would have, that you would use versioning. So let's go ahead and do this. So revisions, you can see they're located over on revisions. So I'm going to add a new revision, call it caching, if I can type. And so now we'll have revision 2 once it decides to come back. Okay, so we have revision 2. An important thing to point out is that it's not marked as current. So no one's going to see the change that I'm working on. You can see I'm working on revision 2. If I pop back to design and select retrieve patient, I'm going to amend this policy to include caching. So I'll look at my cheat sheet. And the first thing I need to do is set up the cache store. So in the outbound policy, I'll cache the response. And what I'm doing here is this is in seconds, so I'm going to cache it for 30 seconds. But of course, the other aspect of this is on the inbound. Before we actually do any of the backend querying, we're going to actually do a cache lookup. So you'll see here, I'm going to vary by a couple of different parameters, but you can get a little bit more sophisticated in your cache lookup. I'm keeping it simple. So I'll go ahead and save this. Now, one of the really powerful things about revisions is no one can see it, so we won't be seeing any impact to the performance, but we can still test it. So I'll use Postman again, and you'll see that we have a revision 2. And hopefully you can see it. It's not too small, but you can see that we specified rev2 in the path. So if I send that in, it looks like it's still working. It's really hard to tell what impact it's doing, but let's say we're happy, we believe it's working, and we're going to go ahead and set that as the current revision. So I'll go ahead and do that. I'll just say make current. I'm not going to worry about making a public changelog, but I'll change that one so that now revision 2 is current. And what we should see is we should see a dramatic change in our test run. So let's just be patient. And we might already be seeing it with that little dip. Oh, geez, that was the opposite of what I wanted to see. It's fun having a live demo. But hopefully now we see it plummet back down. Important, we didn't have a failure, but now we should see the performance change. That's what I'm hoping. And the other aspect of it too, wow, look at that graph all over the place. But we should see an impact to the database, unless I'm proven a liar. Exciting live demo. Well, I'm not going to overthink it. We'll come back and we'll have a look. We should see an impact. If not, I did something wrong, but hopefully you can see where I was going with that change. Right. Going back. Okay, so one reason why I wanted to do this presentation is it provided me an opportunity to explore support for CI/CD. I've seen several attempts to solve how change is rolled out from a development API to other environments. These have been a combination of manual processes, PowerShell, and other approaches, but they seemed error-prone and incomplete to me. I then came across the API Ops. The tool is supported in both DevOps and GitHub. Some of you are probably familiar with a popular ARM-based approach, but let me show you something important if you haven't already spotted this. So this is the Azure API Management DevOps Resource Kit. It's actually in maintenance mode in favor of what we're going to be looking at today. So in this, today I'm actually using DevOps for my for running pipelines, but it's also supported with GitHub Actions. Let me kick off a pipeline, and then I'll explain what's happening. It's right here. Right. So let me just go ahead and start the extractor pipeline. There's a couple bits of information that I need to supply it. I need to supply the APIM instance name, and just so that I don't make a mistake, I'm going to go ahead and copy that over. Whoops, nice. And the resource group that it lives in. So I'll again do the same. Grab the resource group name. The repository is just, you can see it here, the project name. So API Ops. And the folder where I want to place it, and I've just called it artifacts because it seemed like an appropriate name. I'm going to target my target branch. I'm going to keep main. And I'm just going to use the defaults. for our purposes, it's not important to dive into these. So I'll go ahead and kick that off. So while that's running, let's just talk a little bit about what it's actually doing, and then we'll come back and revisit. So nice little graphic that they provided us, but let's just talk it through. So what we've done right now is we just kicked off the extractor pipeline. What that's going to do is it's going to take the current state of the API instance, in this case, the dev instance, and it's going to compare it to the Git repo. If it finds changes, hopefully are a cache change, it's going to head and create a PR. I'll go and review the PR, which merges it back to the main branch, which will then kick off the publisher pipeline, which then will update the API management instance. Later in this presentation, we'll also talk about how we can do this direct in the GitHub repository. So we'll also do that. But for now, let's see how that pipeline's doing. All right, well, so far so good. We have one green. The next step is to actually create the PR. So it's in the process. Hopefully this will work. Nothing worse than when it doesn't work. Shouldn't take long. All right, and creating the pull request. And there we go. Great. So what we should see then is we should see a pull request active that we just created just now. And if we dive into that, we can actually see what files were updated. So popping into the files, again, apology for the size, but hopefully it's not too bad. What we're seeing over on the left-hand side is the structure of our artifacts folder. And so you can see some of the files that were updated by our change. So for example, the policy file of the retrieve patients, we can see our two changes, the cache lookup and the cache store. And we can see also some revision information and various bits and pieces. So we can dive in and look at all the details, but for our purposes, I'm just going to go ahead and approve it. I think it's good enough. And I'll go ahead and complete the PR. So this will then bring it back to main, which, if it was successful, should then kick off the API publisher. So an important thing to point out about the publisher is it's going to update both our dev APIM and our production APIM. And in order to push to the changes to the production, we'll have to approve it. So we'll have to wait until it progresses. Since we have a little bit of time to wait, let's have a little bit more look at the repo file structure. So in artifacts, these are the different files that it's going to build up to describe our APIM. So you can see, that we have a revision 1 of the patient's API, and now we have this is actually our revision 2. And you can see we have both add patient, get retrieve patient, and various bits and pieces about it. Probably the biggest riddle that people are thinking of is how do we control the different environments? That's in a configuration file. So in the configuration file, this will actually update values in some of the other XML files. It was relatively easy for me to get it to work. The documentation's reasonable. To give you an idea, API Ops, they have a published wiki. In there, it describes the publisher, some of the variables that you can control, and it provides a exciting map of how the I know you can't read it, I can barely read it, of how the configuration file maps to the different XML files within the artifacts folder. So it's reasonably well documented. And an important aspect of it too is it actually encouraged me to write my policies in, I would say, probably more of a best practice. So let me give you an example of that. If we pop back to our APIM instance for dev, one of the things that I did is I created name values and backends so that I could actually replace it in that configuration YAML file. So you'll see here we have our add patient queue and the actual URL that it will be using. So our prod instance has the same value, but it's been replaced with, instead of API ops storage dev, it's API ops storage prod. So I think we're all interested to see how that pipeline's doing. Right. So what we're seeing here is it successfully pushed the changes to dev, which in essence, it shouldn't have made any changes at all. Now it's going to go ahead and push the changes to prod. I do need to approve it, so I'm going to review it and say, yep, I think it's good, and that'll then kick it off. So one of the things that I was really interested to find out is what was the impact to a running system. So when I did this before, sorry, I'm just trying to find my, here we go, in the test run, what I found, that's what it is. So you can see now, do you see the caching, how the caching now is reduced it to milliseconds as far as the, the performance of the retrieve patient. One of the important things to point out is we were able to update the service live without an impact to performance, and more importantly, no breaking changes. What I found in practice, because I've obviously done this several times, is depending on where it is in the JMeter script, it could have an impact on performance, but it never failed, which is an important aspect. So this is the dev instance running, and you can see the CPU has dropped dramatically. Let's just see how prod fared during that deployment, or I should say as the deployment. So here we come in. So, obviously we haven't done anything with caching, so the response time is still high. No errors, which is good. Higher requests per second, but that's understandable since since we're running 4 instances of the engine, which equates to more virtual users. And again, no failures. So let's see, has that deployment completed? If we pop back to the pipeline, yep. So it's pushed the changes. And like I said, what I've seen sometimes is an impact to performance, but in this case, it was nice and smooth. So I'm really excited about this because it's one step towards zero downtime deployment, which I think APIM is a great service to really highlight how you can achieve zero downtime deployments. Hopefully there's people on the call who can appreciate the value of not midnight deployments. Right, so going back to the presentation. Okay, next feature I want to talk about was security and authentication. APIM enables organizations to add authentication and authorization mechanisms to APIs using a variety of protocols such as OAuth, OpenID, Connect, and API keys. And I'm going to put in my second poll because I'm also very curious about this from the group. Right. So, what security have you used in APIM? And if multiple, then pick OpenID or OAuth, because I'm curious to hear how many companies out there are actually using OpenID Connect or OAuth, because so far the majority of the companies that I've dealt with aren't using the security mechanisms, or using different security mechanisms. Back to the presentation. Right. And not exactly security, but it's a good time to mention some related features. The subscription key is a way of identifying the caller. In our scenario, we have two external systems. So let me show you what I am describing. So over in our development API ops, if we look at subscription, I've created two subscriptions, one for Galaxy High School and one for Westfield High School, but I just created two separate ones. And what that means is they use different subscription keys. So to highlight this in our in Postman, in the header, we actually specify the subscription key as a separate header, OCP APIM subscription key. There is some flexibility on how that's specified. So popping back to APIM, and we look at our API definition, we can see that in settings, this is specified under subscription. So I've made it so that the subscription is required, and I'm supporting both header name and also as a query parameter. So if a consumer wanted to specify it as a query parameter, they have the ability to do it with subscription key. And again, this is the section I was talking about with the user authorization, where for convenience, I've set it to none. It's also important to point out that APIM also supports other features like verifying certificates and IP filtering. So the developer portal. APIM includes a customizable developer portal that serves as a self-service hub for developers to discover, understand, and consume APIs. It provides documentation, interactive API testing, code samples, and allows developers to subscribe to APIs and manage their subscriptions. We'll not dive into the developer portal in order to spend more time on other features. So I believe this is my last poll, but this is another thing that I'm really interested to hear from everyone on the call. So at your company, is the developer portal being used to communicate the APIs to the customer, and how well is it doing it? Strongly agree, heart, partly agree, thumbs up, and do not agree, smiley. So that's developer portal is probably another feature that I see not used to its full potential. My advice here is to consider how your customers will use the developer portal and only provision if it's required. For example, it might make sense to only provision in one environment. I often see it provisioned in multiple environments, which increases operational and management overhead. In some cases, this could provide an unintentional mechanism for accessing production information. So, yeah, I guess proceed with caution. Monitoring and analytics. I see where I won't spend too much time on it because of time, but I'll click around a bit to kind of show some of the power of APIM. So APIM offers monitoring and analytics capabilities, allowing organizations to gain insights into API usage, performance, and errors. It provides real-time historical analytics, logging, and reporting, helping organizations to troubleshoot and optimize API performance. So let's have a look at that. So on insights, no, not insights. Yeah, on analytics, sorry. We can see, if we just say last hour, we can see some of the activity. So I'm in dev at the moment. We can get a summary of activity. I'm assuming that's related to our cache change. Yeah, and you can see how now the number of cache hits has increased quite significantly. And again, all I'm trying to do is just click around some of the features that would be of more interest. In regard to APIs, we get an idea of which APIs are being called, why it only says add patient, patients API, sorry, patients API, because I only have one API, it makes sense. Operations, we can see the split between retrieve patients and add patients. In my JMeter script, I had it tailored to do more retrieves than adds, so you can see this reflected in the successful requests. And products, I didn't spend time on products, sorry. Instead, I did subscriptions. And here you can see that Westfield, there's more requests going against Westfield than Galaxy High School. Users is going to be very interesting because I'm not highlighting that scenario. And then in requests, we can get more detailed information. So it's pretty good. One feature I wanted to highlight though is its integration with application insights. So if we pop over and look at application insights and do a refresh, what I've done is I've hooked up both dev and production into the same application insights instance because I thought it would be interesting to show, you know, how the well, two things really. One is to show it in one image, and the other is to show that our DevOps pipeline did a good job of actually making sure that we overrode the correct instance of the function app and the storage queue, because it would be very poor if we had production pointing to the dev instance of the database and vice versa. So that was the main reason of just showing this image. And of course, if we look at performance, we'll see what we were hoping to see, where we can see the different messages being displayed independently, and we can also dive into examples. So let's just take a look at the, let's say the patients API. So this is on APIM. And if we dive into one of the samples, what I'm trying to show here is we have both APIM and the function app both contributing to application insights, which then gives us a nice view of, sorry, trying to expand it, of the APIM calling the backend service. So I'm having mouse issues at the moment, but hopefully you can get an idea of what I'm describing here, where it hits APIM on our RESTful API, which then hits the function app on the RPC style API. So of course, this isn't a great view, but you could imagine if we had our other dependencies in here, it could start being a very rich view of the activity. So let's move on, because I realize that I'm a little behind schedule. So policy-based control, probably one of the key parts of APIM. APIM allows organizations to define policies to control the behavior of APIs. Policies can be used to enforce security, throttling, caching, logging, and other custom business rules. Policies can be applied globally or at the API, product, or operation level, providing fine-grained control over API behavior. So let me highlight what I'm doing in the add patient So again, going back to our API in the dev instance, we can see here on add patient, if we look at the policy, this section, let's see if I can zoom in. Right, kind of. Okay. In this set body statement, what I'm doing is I'm pulling the subscription ID and I'm adding it into the payload as the registration source. So this is a great way of in a way providing more of like a multi-tenant situation. Same API, but being able to enhance the data based on who's calling. I could have solved it in a couple of different ways. I could have had the calling system supply the information. The disadvantage here is relying on the calling system to consistently and accurately supply the value. I could also have stood up a separate API for each subscriber with a separate value for each. This might make sense if you have a couple subscribers, but when you have hundreds, then it becomes unmanageable. So great technique for multi-tenant implementations. Right. So scalability and high availability, this is important. So APIM is built on Azure, which provides global scale, high availability, and fault tolerance. It supports auto-scaling, allowing organizations to handle variable API traffic loads efficiently. So I wanted to talk about scaling in a little bit more detail. Important to stress that APIM is not a load balancer. In the example here, we're using serverless resources, so it doesn't really highlight. So instead, let's switch to a scenario where we have APIs hosted on some VMs. So in this case, we're using application gateway to now act as a load balancer to the different APIs. It's worth noting that APIM does have an instance count. Standard SKU allows up to 4, where premium does not have a specified upper limit. Scaling can be manual or auto-scaled based on a schedule or on metrics. It's also worth noting that APIM does support availability zones in some regions, so it is possible to have regional redundancy by spreading the instances across availability zones. Also, it's possible to self-host an application gateway. If anyone on the call has experience with self-hosting, please speak up at the end of the presentation. I'd love to hear about it. APIM is a regional service. Here we see APIM deployed to 2 different regions. We can achieve this by either having a multi-region deployment or by managing the deployment ourselves. The multi-region deployment is available on the premium SKU. This will replicate the gateway component across multiple regions and provide routing based on lowest latency. If we manage the deployment ourselves, we could use a global service like Front Door to distribute traffic. It's also important to stress that APIM has many security features like IP whitelisting, but it does not directly integrate with a WAF. This is illustrating how we can use a WAF at the front door to provide this capability. This is a big topic with many advantages and disadvantages. So at the end, again, I'd love to hear from you about your experiences. Integration with Azure services. APIM integrates seamlessly with other Azure services such as Azure Logic Apps, Azure Functions, Azure Active Directory, Azure Monitor. It allowing organizations to build comprehensive and secure API solutions within the Azure ecosystem. APIM does support managed identity, and it is possible to secure communication using Azure AD role-based access control. I thought it was important to dive into this a little bit, so I will again use our add patient as the example. This step here is where we're using managed identity, and I'll just briefly talk about that because if you're not doing managed identity, I encourage you to. And I've just gone over it where, there we go. No, that's developer portal. All right, this is where someone can speak up if because I'm overlooking it. Oh, security, managed identities. There he is. All right. So here we go. So we have a system assigned identity created, and if we dive into it a little bit, we'll see in the Azure role assignments that we have access to our blob storage, and in particular, the Q data contributor. So so as far as integration with Azure services, something else to show is in the creation of a new API. We can actually create it against different existing services. So for a quick example, if we take a look at what I want to do is I want to take a function app and now expose it within APIM. And there's a wizard where we can actually go in and select an existing function. So you'll see that this one, Merimataka, has a Get Astronomy API. I'm able to select that and build it up. If I hit create, it would create a new API, and it's a nice convenient wizard to set it all up. I'm not going to, so I'm going to cancel that. But there was one thing I wanted to show, which I discovered recently, where you can actually go the other direction. So if I find my function app, there's this capability right in front of me. Don't you hate it when I think when you present your IQ drops by half? There it is, API management. So API management, you're actually able to go ahead and select an existing API management and create the API and link the API together. So it's a nice streamlined way of actually exposing your function apps in APIM. Right. Back to our presentation. So the last feature I wanted to highlight was API bundling. So APIM allows organizations to create products, which are collections of APIs with specific configurations, policies, and access controls. Products can be used to bundle APIs together, create API marketplaces, and onboard developers. Organizations can define product tiers, set up documentation, and manage access and subscription to products, making it easy for developers to discover, understand, and consume APIs. Just to kind of highlight this a bit, let's take a look at the starter project. So if we go back to our dev APIM instance, we have the concept of products. Here we have two that were automatically defined. We have a starter and an unlimited. If we dive into the starter, it actually has a policy associated with it, where it provides both rate limiting, so what 5 calls in 6 seconds, and a quota, which I believe it's 100 in, well, I don't know, whatever that is. Someone can let me know. Right. Now, let's go back and see how the load tests are performing. So we can see we have some variance, but for the most part, it looks good. No errors. We've had a drop in CPU percentage. That doesn't look that exciting. Because I'm in prod. Yeah. Let me just do a refresh. Yeah, there's our drop in the request count. It's taking a little while to refresh. Right, but hopefully that this gives you an idea of how you can, perform load testing against APIM, but also do a deployment without impacting the performance. going back to the demo, let's say the dev team missed something and a mischievous tester found an issue. So let me show you something in Postman. So I've created this query here called add patient. And when we, I had it from the last one. You can see when I hit send, it's actually failing, saying the request body is too large. So let's talk about that. Let's talk about that in more detail. So this is actually what's happening. We're having a failure here when we're trying to add to the patient queue. What we're seeing is a limitation on the message size supported by storage. So each service actually does have a limitation. Azure Storage can store up to 64K. Depending on the service bus tier, you can either have a max of 256K or 100 megabytes. Event Grid also supports varying message sizes. So how are we going to solve this? We're going to solve it by doing a very popular pattern called claim check. And what we're going to do in this situation is in APIM, we'll identify the message is too large for Azure Storage Queue. We then will save the message to the blob storage and instead send a reference to the blob in the add patient queue message. Let's say in this scenario, the team has already updated the function app to handle the claim check pattern. So what we'll do now is we'll update APIM to identify when we receive a large message and implement the claim check pattern. For the grand finale demo, I'll attempt to do this code first from API Ops project. So yeah, this is exciting stuff for me anyways. All right, so if we go back to our DevOps project, we go into the files. I lie. Actually, what I'm going to do is I'm going to do it instead of updating it directly. I'll go ahead and create a branch and make my change on the branch. So I'll say new branch. I'll call it Wellington NET. Create it. This will be a copy of dev. Popping into it here in files, I'll go ahead and modify my API, my add patient API. So we can see here, this is what we looked at before. If I go ahead and add that, edit that, and look at my cheat sheet, because I won't be able to type it without making a mistake. All right, there's a couple things we need to do. The first thing we need to do is we need to identify what the size of the message body is. So I'll go ahead after this step here, and I'll take the content length and add it to the body size. Next, I'm going to make a decision on whether or not to just send the message directly or to send to blob storage. So I'll go ahead and paste that in. Let's just look at this guy in a little bit more detail. So in the choose statement here, I'm going to determine how large the body size is. So if it's over 60K, I'll go ahead and send it to blob storage. So you can see here where we're doing a send request, again, using the definition that's provided by Microsoft, and we'll go ahead and set the URL to the blob file name, which is defined here. Basically, the storage, claim check storage with the request ID of the context to ensure that we don't have any collisions. It's a put method. We need to add some header information, including the type, which is blob. We're going to set the body then equal to the message that we received. And again, we're going to use managed identity. What we're going to do now, and this is probably the more interesting bit, is in the set body here, we're going to have basically like a keyword to say what the request ID is. This will trigger our function to say, this is the claim check, and to go ahead and retrieve from blob storage. Otherwise, we're just going to go ahead and do what we did before. So I'll just remove these two lines because they are now located on line 28 and 29. All right, and that's it. So I'm gonna go ahead and save. And if someone noticed a typo, it's probably a good time to speak up. But let's say I did it correct. I'll go back to my branch. Sorry, I won't. I'll go to pull request, and I'm going to create a new pull request, and I'm going to go from our Wellington .NET back into main. We can see that there's only one file that's been updated here. That should be our changes. Yep. And I'll go ahead and create that pull request and go through a rigorous approve procedure and complete it. So in theory, then, that should have kicked off our pipeline. And here he is here. So while this is running and hopefully updating correctly, why don't we dive a little bit into what these pipelines, how these pipelines are actually put together. So let's see, important thing about it is in the, there's a couple of interesting pieces to this. So instead of looking at all the fancy purple text, why don't instead I'll go straight to tools, pipelines, and we can actually see the definition of the YAML files that I'm created. So this is where if you had bespoke functionality that you wanted to do as part of your publish or extract, you can add it here in the YAML file. An important bit to note is if we dive into the publisher with environment, so basically run publisher will call this one depending on if it's dev or prod or UAT. If we look at that in more detail, we'll see that it will actually download, trying to spot it here, the a release that the team working on API Ops has created. So if I take that and have a look at it, you'll see that there's different releases available, hopefully, right? So the release that I'm calling is actually 404, but you'll see that they're on 413. You can get an idea of what's changed, but you'll see the different releases. So as they fix the bugs, you can see they've doing a good job of documenting what's changing. So why I said 404 is it's actually going to pull this from a variable. That variable is defined in my library. So if we look at APIM automation, this is what I was referring to, version 404. So when I'm ready to go to a newer version, it's as simple as going and updating this value, and the pipelines will then retrieve a new release. Going back to our AP Ops publisher. Oh, look at that. Good news, green. If we, there's another feature I wanted to highlight. And this is, again, you can add additional steps, but there is actually a lint step. I don't have a lot of experience with lint, but it's just interesting to note that it's actually pulling it from, again, whoops, a community defined rule file. So there's no reason why you wouldn't be able to host your own YAML file and use that for some specific rules. Here we go. So mine at the moment is showing 10 warnings, but I have found when I've done some modifications that I actually do get errors if I was to forget a particular policy that has been defined in that rule file. So it's a nice touch in order to raise the quality of the APIM APIs that are being defined. So for completeness, I'll just go ahead and approve that. Review, approve, but let's just make sure in our API dev instance that it actually did the change. So I'm expecting it against our add patient. And I'm hoping in add patient, we now see, oh, that's good. That's a good sign. We see the body size and our changes. So in theory now, if that's the case, we should be able to go back to Postman and rerun this. And it thought about it, but it looks like it's now fixed. So that was my grand, exciting demo of improving it. Oh, and just I forgot to highlight, but you can see in the notes section here why it was of a large size. So good that the tester discovered that before we actually had that issue in production. Right, that's it. Thank you. I realize I went for a long time, so maybe there's only one person left, but thank you for listening, and please reach out on LinkedIn. Love to hear from everyone on the call now. Things that you liked, and also your experience about APIM.
That's cool. Thanks, Jeff. We have a couple of questions in the chat. Can you see that?
Yes. Yeah. So this is first Marcel's question. Are there any considerations with API ops when it pulls artifacts? So I'm really at the beginning of my learning of API ops. I really wanted a realistic like scenario to start exploring, and I have learned quite a lot about it. But I know if I was actually doing this, full time as an APIM developer, then I would learn a lot. But yes, the consideration in particular is what I found is you have to plan for how you're going to overwrite values when it moves to the different environments. So I only have two. I have dev and production, but I would imagine not most, but there's going to be lots of situations where you're going to have dev to UAT to, I don't know, maybe sit, different environments. So how you define your APIs is very important. So I might not have been, I know I went really fast, but you'll see what I've done is I'm defining backend services, which makes it much easier for me to replace those in the configuration file. So the configuration file being this file defined here. So that would be an important consideration, but I'm sure there's tons of other ones that will also get you. Is the DevOps YAML part of API Ops? So yes, in the sense that you pull these down into your own repo, and you can customize them. You can add steps. If you didn't want the lint, you could remove it. But it does, as part of the startup, it actually will pull down their release. So there's part of it that's going to be inside of your repo, and another part of it that's going to be a release, which is good because you have some flexibility, but also you're getting you're able to leverage an open source community.
Cool. Thanks. Do we have any other questions? Yeah. Maybe I can ask some questions, Jeff. I do have some questions. The first one is I saw you in your demo you shared we can set up the cache in APIM. Also, I wonder what the difference is between the APIM cache and in application we can also provide some cache like in memory cache or distributed cache. So what's the benefit using APIM cache over the difference?
Well, the main benefit is then you're putting the pressure on APIM in order to do that. I mean, you can still do in-memory cache, of course, in your applications, but the idea is to stop it at the as close to the customer as possible. In the load balanced in the globally load balanced scenario, we had front door. Front door also has a really great caching mechanism to it too. So it's sort of, it's a design decision on where you want to put it. A lot of the solutions that I've seen come on have been existing, and so they already had an existing caching strategy. So in that case, I wouldn't suggest, ditching something that's already existing and working for using the APIM one. But I have seen in a few scenarios it actually quickly add a lot of value, where a lot of times, if someone's hitting your system very aggressively, multiple times per second, the value is not going to change, between calls. So it does make sense to look at these features.
So what kind of cache patterns it supports? Like, in if we implement the cache in the application, probably it supports some like a slide window or some other patterns. Can APIM cache support that kind of different patterns?
So the example that I used did a 30-second, but I'll pass on getting myself into trouble trying to explain something that I don't know as well as I should. But yeah, they're in the documentation, when you look at the different policies, there are some flexibility with what you can define, whether or not you have a sliding one, and or how it decides what gets removed from the cache. I'm sure it's documented, but yeah, no, I don't know offhand. Yeah.
Thanks. My next question is, also, so in your demos, you shared how we make the versioning for APIs. So from your experience, what's best practice of using versioning? Do we put the version in the URL or in the HTTP headers? I think there are some different approaches.
Yeah. So what I've done is I've added at the end some useful links, because there's some big brains out there who have great information on this. So it's probably more important to be consistent than it is to follow to be inconsistent as far as how you're communicating to your customer. So I think that's probably the real strength of APIM, is that it has a versioning strategy you can choose, in the path, or as far as a parameter or whatever. But in the documentation, the architecture center, I think it's here. Yes. There's some really good information on, REST, not REST. Also, you'll find information on breaking changes, and also versioning. So you can see that there's different versioning strategies that they'll describe, but they'll do a much better job than me trying to summarize in 30 seconds. Sorry.
Yeah. That's cool.
It's a great question, and you I think we all have tried to answer that in in our roles also, because it's it's very common. What versioning practice you have. The whether it's REST or RPC, my opinion is that's a design choice, depending on your consumers. That's probably not popular. REST is the popular pattern. But in some situations, if you so for example, if your customer base isn't as sophisticated as you are, if you're pushing workflow and or a complex set of business steps on them, a lot of customers, not a lot, some customers aren't able to do that. So it sort of depends on your customer. Sometimes it's easier to have an RPC style that takes 30 REST-like steps combined into a single package for these customers, that it would be really challenging for them to actually implement that as separate REST statements. But it depends. Nice thing about REST, as developers, you define REST and then you just let your customers consume it how they want to. It's again a design decision, and there's a lot of factors.
Oh, great. Also, I think this documentation is really helpful. Can you share the link in the chat?
Oh, yeah. So what I'll do is
Yeah.
I can post each of these that I think are really useful URLs. I can post those in the chat, and
Yeah, that's cool. Do you have any other questions, everyone? That's a great session. I saw lots of demos. It's quite engaging.
so anyone on the call actually do they have anything they want to share? Because I'm genuine in wanting to hear like if people are using so if I look at it, so I see someone saying that the developer portal, their company's using it. My experience is I've I've seen it as a developer-led initiative, but it never was communicated strongly to the customer. But I'd be curious to hear how whoever did the comment, how they were able to actually get the customers to consume it, or was it a particular type of business scenario? I don't know if they're still on the call. Oh, was that you who did the heart? No? Yeah, you did the heart.
Yeah,
Yeah.
I think I've used the developer portal a long time ago. I think
Yeah.
quite convenient.
It's really good. I think it's a great idea, but it's what I was talking about at the beginning, where it's you know it's the business aspect of it is we can create this great portal, but unless we know how to deliver it to our customers and get our customers to use it, then what we end up doing is we write a Word document to send to them to describe how to use our developer portal, and it sort of defeats and we supply them with the Postman project, and so it defeats the purpose of this developer portal, because it's incredibly powerful, but it's how do you communicate it? How do you get your customers onboarded? And I would think it depends a bit on who your customers are. I think like a SaaS solution, it would probably be really it would be more successful than if it was like a business app, especially like an internal business app. Then
Yeah.
The other question is, did we have anyone who actually did self-hosting of their API gateway? Has anyone ever done that? I would be surprised if anyone has, but it'd be great if someone has. No? Okay. I was just curious because it's a great idea of scaling it, of high availability or scaling it out, but it's so easy to stand up an APIM that I'd be surprised about the self-hosting side of it. But there you go.
Yeah. Hey Marcel, do you have any comments or opinions on that? I forgot to introduce Marcel, also a Microsoft MVP. Right? Yeah. So if you have any comments, feel free to turn on your microphone. Let's just join the discussion. No mic. Okay.
No mic. Okay.
It's all right. Yeah. Cool.
Yeah.
Thanks, Jeff. Any other questions? I think we already it's 1.5 an hour. That's really insightful presentation. Yeah, lots of cool stuff. If we don't have more questions, I just want to thank Jeff for your fantastic presentation on Azure API Management. Oh, we do have a new message. Was a good example.
Good example. Yeah.
Yeah. Thanks, Aaron. Yeah, really appreciate your presentation. And thanks for your insightful and engaging presentation and demos. Really appreciate your focus on, especially for the API ops and how it can help developers with CRTD, something like that. Yeah, so thanks. Also, I'd like to appreciate all the attendees today. Thanks all, and hope to see you all next time. Thanks, Jeff. Yeah.
Yeah. Thanks. I appreciate it.
Thanks
Yep.
all.
Thanks, Jeff.
Yeah. Thank you.
Yes, Jeff.
Right.
Yes.
I'll stop recording.
Hey, Gopal,
Okay.
I see you're online.